This dash is lit up like a Christmas tree. Two things are gonna happen. Either panic's gonna set in, or you're gonna say, there's that check engine light again. Either way, no worries. It's just trying to talk to you. And today on Tech Garage, we're gonna show you what it's saying. Welcome to Tech Garage, presented by Advance Auto Parts. I'm John, and I'm going to take the fear and despair out of that check engine light. And we also have a TPMS light, tire pressure monitor system, that's on this vehicle, and we'll take a look at that later. But let's start with Onboard Diagnostics 2. Now, Onboard Diagnostics 2, what is it? Well, it's a system that came about in about 1983 was Onboard Diagnostics 1, and then 1996 was Onboard Diagnostics 2. So if you have a 96 or newer, you're dealing with a system like this. Why? Emissions, gas, CAFE, everything that had to do with computers. Remember, carburetion's gone. We're talking about fuel injection. Couple things we need to look at. First of all, is a data link connector right here. This is called a DLC. This is a 16-pin connector. This is how you're going to talk to your car. That check engine light wants to talk to you. This will do it. You can use either a scan tool here with a little pocket scan tool or professional scan tool. Doesn't make any difference. It's going to communicate to the car. Couple things to keep in mind. There's inputs and outputs that are going on with this system. Inputs, well, think about your nose, sensors, eyes, ears. We have sensors like the engine coolant temperature sensor, intake air temperature sensor, map sensor, throttle position sensor, mass airflow sensor, are all reporting to this computer here. And as they report to that computer, the computer decides what's going on. He sends some outputs. Well, outputs, your hands, something physically going on. Idle air control motors, they move, control and idle. Injectors pulse fuel. But the deal is, they all work in concert with each other. The inputs talk to the computer determines the fuel delivery, and I can start it up here. And you can see what's going on. All the sensors are talking to the computer, and the computer's mixing that perfect fuel delivery. But what we need to do is take a closer look at those sensors, and we'll look at them next. Now let's take a look at some of these sensors more in depth. We got the inputs and the outputs. We'll start with a few inputs. The first one here is the oxygen sensor. And what does it do? Exactly what it just said, oxygen sensing. It's in the exhaust stream and it senses the oxygen that goes through there. If there's a lot of oxygen, it's lean. If there's not much, it's rich. We'll move up here to the engine coolant temperature sensor. Now this engine coolant temperature sensor sits right in the coolant. And what it does is it senses the temperature of the coolant. It's a thermistor. What it does is by varying its resistance, it can actually tell the computer what temperature the actual coolant is. Then you move up to the intake air, it works the same principle as the coolant temperature sensor. The next one up here is a MAP sensor, manifold absolute pressure, and that's hooked up to a vacuum source. And what that does, think about it, if you have a lot of wide open throttle or you're going real fast, you're not going to have a lot of vacuum. This will tell the computer. Come over to this side here, we actually have a throttle position sensor, TPS. And what you do is sweep that back and forth. It's connected to the throttle, and that tells the computer where the driver wants the throttle. Now, you can have a cable-driven one, or you can actually have an electronic-driven throttle. If you have electronic-driven throttle, you're going to have an accelerator pedal position. So when you push it, it'll tell the computer, and it'll actually move the throttle. That's a lot of inputs. There's some more outputs, but first, we have with us Philip Austin from Standard Motor Parts.
Hello, John.
Hey, thank you for coming. Listen, our viewers want to know a little bit more about these sensors. Have you run into any problems, or what can you share about all these sensors?
Yes, the sensors play an instrumental role in managing the engine. However, the main culprit of failure within these systems to cause the check engine light is not just the sensor itself, it can be a power or a ground loss. So it's very important when you have a code related to a sensor to check powers and grounds first.
That's absolutely true. So you mean if I scan it with a scan tool and I come up with a P123, it may not be the throttle position sensor, it could be the circuit?
Absolutely.
And what about this electronic throttle? That's pretty cool. We used to drive cars with the actual cable. Used to. Now it's electronic. You push the throttle, you have absolutely no control over that throttle whatsoever. The computer's doing it.
Yes, indeed. Now here's the thing. You could get a P0123 and the circuitry is still within this electronically controlled throttle body. So what you would have to do is use a wiring diagram to figure out the circuit and test each wire going through the throttle body to ensure that you're getting the proper powers and grounds.
Wow, yeah, there's a lot to it. Now the outputs, fuel injectors, idle air controls, same concept?
Yes, pretty much. And keep in mind, relays play a very important role in powering up the computer and most of the actuators that the computer is controlling. So it's very important that you make sure that the computer is activating the relays for the circuits related to operating the engine and managing all the related systems.
We'll be right back with more Tech Garage, presented by Advance Auto Parts.
Tech Garage is brought to you by Advance Auto Parts. Let's get you back to the garage. ARP, the world leader in fastener technology. Race Gas, get more out of your engine. And by Standard Motor Products. When OE fails, trust SMP brands.
Welcome back to Tech Garage, presented by Advance Auto Parts. Now, I just hooked up the wireless connector to the DLC, the 16-pin connector we looked earlier, that's up under the dash. And lo and behold, we have a code. We have a code here that's a P0301. Well, what does that mean? The first letter P stands for powertrain. If it was C, that would be chassis. If it was B, that would be something to do with the body control module. And U codes are network codes. The next number in there is 0. 0 means it's a generic code. If it was a 1, that would be a manufacturer-specific code. And then you have the 3, which is actually the system. That's an ignition system problem. And the 01 is the exact code. That's a cylinder, misfire 1. And below that, we have another one that has to do with the ignition system. But before we can diagnose it, the first thing we need to do is we need to take a look at ignition systems and the fundamentals of them and how they work. Well, the first thing a lot of us will remember is distributors. This is a distributor with actually points. You guys remember the points when we used to adjust the points and go through there? Now, as this spins around, it's going to open and close these points. When it opens and closes the points, it creates a magnetic field, bam, shooting that spark to the cylinder. That's where it all started. From there, we went to distributors. Now, on a distributor system, you have a primary side, which is usually all the small wires right here. Then you have a secondary side of ignition system. That's the heavy wires here that go down to the spark plugs. And this one here is a distributor, but it's an electronic distributor. So we went from a regular contact points to electronic distributors. Now, if I turn this on, what's happening here is this distributor spinning and it's coil saturating. When the computer actually opens up that primary side, it induces a big spark into the secondary, and that's what you're seeing here at the spark plugs. Now, if I pull this cap off, you can see what's going on inside of here. The distributor's turning, you got an ignition module, and right here is your rotor. As your rotor spins around, it distributes the sparks to the cylinders just at the appropriate time. Next over here, in the evolution, we have distributor-less ignition systems. This is an actual waste spark principle. What happens here is we have a cam position and a crank position sensor, and that's telling the ignition module or the computer when to fire and what to fire. So if I turn this on here, you can see he's reading the sensors, and what he's doing is he's actually opening and closing that primary side, inducing that spark into the spark plugs. You can see these spark plugs are firing. Now from there, same principle, we went to coil on plug. Now, coil on plug, everything's the same. I got a coil here, I got the spark plug wire, just a neat compact package. That's what our truck has, and later we'll address that code. But there's a lot of other sensors, and there's some different components on here. Philip, why don't you come back in, and you can actually tell us a couple things that you can elaborate on these sensors and that code.
Yes, when it comes to the ignition module that's in the distributor cap, it's very important when you're replacing the distributor cap to check for moisture, because that's enemy number one that could cause a high failure rate with the ignition module that's inside the cap. On a DIS system where you have a cam and a crank sensor, sometimes there's an updated part in the box for the crank sensor, because with the crankshaft being the main source of the signal for the crankshaft sensor, at times due to excessive engine wear by not changing the oil, the crankshaft bearings may wear and could cause damage to that crank sensor. So putting a new crank sensor on will not fix the problem. So look for a problem-solving solution for a crank sensor, meaning having extra shims in the box so you could space out the crank sensor to accommodate the engine wear.
Okay, so as that thing starts to wear, what's happening here is you're actually getting a distance between there, and if you get a distance between there, what's going to happen is it's going to lose its signal.
Yes, and that's a problem-solving solutions on GM Vortec engines, the 4.3 and the 5.7 from 1996 to 2002.
Well, that's going to be a big help. You know, next we're going to walk over and scan this truck, but before we do that, we got some emails to answer.
And now the email question of the week, presented by Advance Auto Parts.
John, we've got an email question here from Dan in Fort Lauderdale, Florida. Dan has a 2010 Chevy Silverado and recently had the computer scanned. The code that came up was a P0442, and they told him it had to do with the EVAP system. Now, this is right in line with what you're talking about today. Any advice for Dan?
Brian, I think I got the answer for Dan. What you have here is a PO442. That's a small leak in the EVAP system. Now, the EVAP system's job is to capture any fumes in the fuel system, either when the car's running or not running. And what it does it with this charcoal canister and a few solenoids, purge solenoids, vent solenoids. If there's a leak somewhere, you can take this smoke machine, stick it in there, look for the smoke. That's where it's leaking. If you don't have one of those, pressurize it for air, but you have a leak in your EVAP system. It may be as simple as the gas cap. Just look around, find the leak, clear your codes, you'll be good as new.
If you have a question for Tech Garage, email it to techgarage@advance-auto.com and be sure to watch to see if your question makes it on the show.
Welcome back to Tech Garage. Now it's time to go up under the hood and find out what's going on with that misfire. Remember earlier, we had a code P0301, and that told us we had a misfire on cylinder number 1. Now, the easiest thing to do is go ahead and get a spark tester and see if we have spark in that cylinder before we do anything further. So what I'm going to do is take this spark tester right here, and what this is a predetermined gap in this spark tester. It's good to use these because the coil has to build up a little bit of power to get through this gap, just like cylinder compression would. So I come down here, and I disconnect the spark plug wire, and I'm going to connect it right to that. Find a good suitable ground for it. Make sure I'm clear. I don't want to get hit with that spark. Then we'll go ahead and crank up the truck. Straight. Well, there's no spark. What does that tell us? Well, that tells us nothing's coming from the coil. We don't even know right now if we got any primary wires or the coil opening and closing. So what we would do, or a professional technician or a professional shop's got access to this MotoLogic right here. And what this MotoLogic is going to tell us exactly what's going on with the complete system. You can see here, here's our coil number 1. We have a ground wire, a reference low wire, the control circuit, and the ignition circuit. So what's going on is the computer's opening and closing that primary side, inducing a voltage into the secondary side, and allowing that spark plug to spark. Now, we took the liberties to go ahead and check that side. Everything was working great on this car. Our coil was pulsing, we had power, we had ground. We checked our spark plug wire, so the only thing left was the coil. Now that we got the coil, we'll go ahead and put it on, make sure it works. So I'll come down here, get the coil mounted back up first. Don't forget about both your bolts, and you also have the primary wires there. Now sometimes these coils go directly onto the actual spark plug, coil on plug. This one's a little remotely accessed, so you have a little spark plug wire that goes to it. Snug it up, make sure it's good. Then we can come back and plug in our primary wires right here, make sure that's secure. And now that's all that's left is to put the spark plug wire back on. Now we checked this one earlier, but I want to go ahead and show you because this is something you can do right out in the garage. You can take your spark plug wire and you can set your meter up to ohms of resistance. And you can come in one side and you can touch the other side of the spark plug wire. And what I'm getting is 798 ohms of resistance. That's perfect for this wire. I checked the spec earlier on MotoLogic. Now, averages anywhere from about 500 to 1,000 ohms per foot, but check your service manual or your specs for the vehicle you're working on. Now what I need to do is come back here, connect the wire. And before I put it on the cylinder, I'm going to go ahead and run that spark test one more time just to verify the repair. Now what we'll do is we'll crank it up and hopefully see some spark. Great. We got a good spark, so we fixed this problem. All that's left now is we need to clear the codes, hook the spark plug wire up, and take a test drive and verify the repair.
How does your vehicle's computer determine which engine cylinder is misfiring? A. Voltage drop across spark plug wires. B. Difference in crankshaft rotational speed. C. Throttle position sensor voltage readings. Or D. Variations in coolant temperature readings. The correct answer is B. Some vehicles watch the camshaft position and crankshaft position sensor for crankshaft speed variation to determine which cylinder is misfiring. Tech Garage is brought to you by Advance Auto Parts. Let's get you back in the garage. Standard Motor Products. When OE fails, trust SMP brands. Steel Rubber. Quality crafted rubber parts and weather stripping. And by Custom Auto Sound, the originator of classic car OEM fit radios since 1977.
Welcome back to Tech Garage, presented by Advance Auto Parts. Now, we took care of that P0301 misfire, fixed it, took it on a test drive, and it's running like a top. Now we have to address that TPMS, tire pressure monitor system light that was on. Now, a tire pressure monitor system senses the pressure in the tires. Now, it can do it one or two ways. It can do it indirectly by using either the ABS unit or the tire pressure monitors, computers, and it actually looks at the tire and the rotational speed. What happens is the air starts to decrease, the rotational speed of the tire is going to decrease, and the computer is going to recognize that. But most vehicles 2007 up are going to have tire pressure monitors. This one here is an actual direct system, and that's what our truck had. And what happened with our truck is when we turned the dash light on, it was solid. So that told us it's going on something down in the tire. But if it was blinking, that would be a system problem. So what we did is we just simply went around, checked all the tires, and guess what? This one was low. We filled it up, we're good to go. Now remember, when it gets cold, tire pressures are gonna change, hot, they may fluctuate a little bit, so just put the manufacturer's suggested tire pressure in your tires and you should be fine. Now on this direct sensor, this is a radio frequency. What this does is actually sends a frequency to the tire pressure monitor and it knows the pressure of the tire. You can have it mounted here in the valve stem. This is an actual tire right here in the valve stem. The tire would ride right here. Or you can have a band type. Now the band type is going to be strapped around the whole entire rim and then the sensor will be on the band. So if you or a tire shop's messing with any of these, you need to be aware that that's right there and be careful about it. Well, what I'm going to do is I'm going to go ahead and just pull this out because I got some special tools here from Bartech that actually will help. This is going to take off the nut on the Schrader valve right here. And if I pull this out, I can push the sensor out. There's a little grommet right here to seal it. That grommet's going to seal that up. Now, also in here, there's a Schrader valve. Make sure you keep the Schrader valve to the tire you're dealing with because the Schrader valve is a special Schrader valve for that tire pressure monitor. You can see it right here. I'll go ahead and pull it out for you. All right, and there's the Schrader valve right there. Make sure that stays intact with the tire pressure monitor you're working on. Putting these in, another tricky situation. You don't want to apply a lot of pressure to this because you could damage the sensor. So what I'm going to do is I'm going to put it back in here. Just keep that in the mind, whether you're doing it at the house, because what we have from Bartech is a kit here. And what this does, it actually spins. And when it spins, you'll hear it. Break free. As soon as that breaks free, no more torque can be applied. That's keeping our sensor safe. Now, a couple other tricks. If you ever rotate your tires or a shop rotates your tires, what you're going to find is he may be in the wrong position. You have a digital dash. It's telling you the right front's low when it's really the left. So what we need to show you is the relearn procedure. Now, in order to relearn where these sensors are, so the digital dash can tell you the right front's in the right front, the left front's where it's supposed to be, anytime you rotate your tires, You can use either a professional scan tool like this, you can pick up one of these. This will actually shoot the signal into the actual sensor from the outside of the tire. Just point it where the valve stem is, shoot it in there, it wakes it up, it learns the procedure. But I'm gonna show you a trick with this truck you can actually do right at home. You can take the key fob on this truck. It has a procedure. Now the key fob, what I'm gonna press here is I'm gonna press the lock and the unlock button together. Now that's not all vehicles, but on this one. And what should happen is it may go into the relearn procedure. Well, how do we know that? It's gonna honk the horn. When it honks the horn, it should turn on this first light. I don't know which light, but usually the left front light. What does that mean? Well, once again, that's the tire. It wants to know where it's relearned. How do we do that? Come on down, let the air out of the tire. So let's give it a shot. Hold both the lock and unlock. Beep twice, and the light lit. So we're in good shape here. It wants us to do this tire, the left front tire. Now all I have to do now is come down here and simulate the tires going down, so I can come down here and let air out of the tire. When we're letting air out of the tire, the pressure sensor's recognizing it. The computer's recognizing it. And he says, hey, that's the left front tire. Then what happens is, go ahead and let the air out of this one. It might take quite a bit of air because it has to see a big difference. So once it sees a lot of air out of there, it'll honk the horn and it'll tell me to move on to the next tire. Now, where do I find the next tire? Just look at the light. The next light's on and you'll do the same thing. Nope, there it goes. Now all you need to do is go to each wheel indicated by which light's lit. Do the same procedure till the horn honks. When you get to the final wheel, the horn will honk twice and your relearned procedure will be complete. Now, throughout here, we saw the check engine light. We saw the tire pressure monitor light. You know, there could be stability control, traction control, ABS, but no worries. You should now have the confidence to go out and tackle any one of these. You know, we're about out of time. Thanks for watching Tech Garage, presented by Advance Auto Parts.